Okay, my name is Nufata binti Muhammad Azali. Today I would like to show how to solve the system of equation using the Gauss-Seidel method. Okay, here we have three equations, which is 45x1 plus 2x2 plus 3x3 equal to 50x. And the second equation is negative 3x1 plus 22x2 plus 2x3 equal to 47. And the last equation is 5x1 plus x2 plus 20x3 equal to 67. Okay, for the solution. First, we need to convert it from the three equation. We can see the variable we have here is x1, x2, and x3. Okay, so we need to convert it into metric form. Okay, what we can see here, I have done to convert it into the 3 times 3 metric. Okay, after we convert into the metric form, we need to arrange them into x1, x2, and x3. Okay, here we have x1 equal to 58 minus 2, x2 minus 3, x3 divided by 47. And for the x2 is, we will get x2 equal to 47 plus 3 x1 minus 2 x3 divided by 22, and the for x3 is equal 67 minus 5 x1 minus x2 divided by 20. Okay, you need know uh, along the calculate, we will use what the S1, S2, and S3 for you. So for we can put in the value until the end iteration. Okay, hence the given system of equation are strongly diagonally dominant, which ensure the converge of approximation. Okay, let's take the initial approximation, which is x1, x2, and x3 is equal to 0. Okay, next we continue with first iteration. Okay, for at the first iteration for x1, after we put in the value, we will get x1 is 1.2 x 9, for x2 is 2.31212, and x3 is 2.91217. Okay. Okay, we continue with second iteration. Okay, for second iteration, the value of x1 we will get 0.9919x, x2 is 2.0069x, and x3 we will get 3.00166. Okay, because of we can't get the converge value yet, we will continue with third iteration. So for the value of x1 at the third iteration, we will get 0.9995x, and x2 is 1.99979, and for the x3 at the third iteration, we will get 3.00012. Okay, we continue with fourth iteration. Okay, for at the fourth iteration, for value of x1 is 1.000, and for the x2 is 1.999, and x3 is 3.000. But we can see the we have near to get the converge value. Okay, likewise there will be modification in approximation with each iteration. Okay, here I have go in the table, we can see for first iteration, two iteration, three iteration, and four iteration. For value s1, s2, and s3, we can see on the at the third and fourth iteration, the value for s1, s2, and s3, it become the near converge value. Okay, after the fourth iteration, we get, okay, here we calculate to know the value of error in magnitude. Okay, so we calculate between iteration 4 and 3. So here I have calculated it. Okay, for x1, for the iteration 4, for the value of x1 minus for x1 at the iteration 3, we will get 0.00042. Same like for the value of x2 between iteration 4 and 3, we will get 0.00020, and the value 3, we want to know the value of error between station 4 and 3, we will get 0.00012. Since all the error in magnitude are less than 0.0005, so the required solution is we will get the value of x1 is 1.000, x2 1.999, and for the x3 is 3.00. No, we don't done yet to answer the question. We need to run off the 3 into the 3 decimal place. We get x1 is 1, x2 is 2.00, and x3 is 3.000. So the problem for question is solved.
Assalamualaikum and hello everyone. My name Nurul Najwa binti Ahmad. My metric number D2021095696. So today I will explain the solution for the system of linear equation using Gauss-Jacobi. The question is, consider the linear system of equation below. Equation 1, 45x1 plus 2x2 plus 3x3 equal to 58. Equation 2, negative 3x1 plus 22x2 plus 2x3 equal to 47. And equation 3, 5x1 plus x2 plus 20x3 equal to 67. Use the Gauss-Jacobi iterative techniques with x not equal to 0 to find approximate solution to the system above. Alright, for the solution, iterative methods to solve system of linear equations by Jacobi's method. First step, we rearrange the equation such that x1 equal to negative 2x2 minus 3x3 plus 58 divided by 45. For x2, 3x1 minus 2x3 plus 47 divided by 22, and x3 equal to negative 5x1 minus x2 plus 67 divided by 20. To find x1, x2, x3, let's start with the initial estimate given as 0, 0, 0. So we will start with x1 equal to 0, x2 equal to 0, and x3 equal to 0. Okay, let's do the first iteration. The first iteration is denoted as x1. Now we have x1 equal to negative 2x2. Here, refer to by this value x2. So 0 minus 3. The x3 also 0 plus 58 divided by 45. Okay, we have 1.2889. Now, x2, look at the second equation here. 3 times 0 minus 2 times with 0 plus 47 divided by 22. So 47 divided 22 is 2.1364. And then x3 using x1 equals 0 and x2 is equal 0. So I have negative 5 times with 0 minus 0 plus 67 divided by 20. So we have 67 over 20, so which is 3.3500. Okay, so this is the solution that I obtained for the first iteration is x1 1.2889, for x2 2.1364, and for x3 equal to 3.3500. Okay, now continue doing second iteration. My second iteration is denoted as x2. So go back to the same arranged equation and substitute value x1, x2, x3 that we got from first iteration. X1 will be 0.9706, x2 equal 2.0076, and x3 equal 2.9210. So here is my second iteration that I have obtained. After that, we need to continue doing this iteration until we get the converse solution. We find third, fourth, fifth, and sixth iteration until all the solution converge. Finally, I got the converse solution at the sixth iteration. The solution that I obtained from sixth iteration is x1 equal 1.000, for x2 is 2.00, and x3 equal 3.00. That's all from me. Thank you.
So next, we continue with coding. First, coding is Gauss-Seidel method in Mathematica. Next, we let the linear equations that we use as a matrix A in the coding, which is row 1 45 2 3, and then row 2 -3 22 2, and lastly row 3 5 1 and 20, and then at the back of the equation, which is 58 47 and 67, we let as matrix B, and then we let the approximation, first approximation x1 with 0. Okay, next we continue with D1 as diagonal A, which is 45 22 and 20. Why we get that? 45 in row 1 and column 1, 22 row 2 column 2, and lastly 20 in row 3 and column 3. And then D2 as diagonal matrix D1, which is 45 0 0, then 0 22 0, and lastly 0 0 20. So we can see that 0 0 as upper triangularized and can be lower triangularized. So L as lower triangularized, A minus D2. So we will get 0 0 0, -3 0 0, and 5 1 0. And then for the upper, which is U, upper triangularized, A minus D2. So we will get 0 2 3, and then 0 0 2, and lastly 0 0 0. Okay, next we inverse the diagonal 2, so we will get 1 over 45 0 0, and then 0 1 over 22 0, and lastly 0 0 1 over 20. And then for the end, for answer we will get 0.038334, 0.0171254, and lastly negative 0.00967805. And then we do some codings by using the formula, which is x n plus 1 equal to linear solve d2 for the diagonal 2 plus L lower triangularized, and negative u for upper triangularized, multiply with Sn, which is for iteration, plus b. So we need to find the iteration until the answer we get is converged. Okay, for the last step, we do for 10 iteration, which is we start with first iteration, we will get answer 0 0 0, and then we can look here that in 6 iteration we start get 1 2 3, and then until 10 iteration we still get the same answer. So that's mean it shows that it converges.
Hello. So next we will solve the question using Jacobi method in Mathematica. So for the first step, we will write the question in matrix form. So matrix A is 45 to 3, negative 3, 22 to 5, 120. And matrix B is 58, 47, 67. And the initial value of x, we will put 0, 0, 0. And then we will get the diagonal matrix, which is the D2 diagonal matrix of D1, and then the lower triangular matrix and also the upper triangular matrix. And then this here is the command to get the solution in 10 iteration of the solution. And then these are the iterations for the solution. We can see that the solution actually converge during number 8, which is the seventh iteration. So the answer is x1 is equal to 1, x2 is equal to 2, and x3 is equal to 3.
Mm. What is the difference between Jacobi and Gauss-Seidel method based on the between two calculation between Jacobi and Gauss-Seidel? The only difference between Jacobi and Gauss-Seidel method is that in Jacobi method, the value of variable is not modified until next iteration, whereas in the Gauss-Seidel method, the value of variable are modified as soon as new value is evaluated.
So now we will talk about the difference between Gauss-Seidel and Jacobi. So we can see here that the Gauss-Seidel, the solution actually converged earlier, which is during the fourth iteration. On the other hand, the Jacobi method, the solution will actually converge during the seventh iteration. So the reason for that is because in Gauss-Seidel, the value of x is updated, always updated from one step to another. On the other hand, in Jacobi method, the value of x is only updated during the next iteration. So that is the main difference between Gauss-Seidel and Jacobi.